Hello, guys, and welcome to this very last webinar of this month's APAC webinar series. Um, and I'm Ashutosh. I'm a part of the developer relations team at R3. And today we are going to take you through one of the very well-known feature of Corda, which is the token SDK. The token SDK has been around for quite some time. We did release this as part of with Corda 4 actually, and then it has gone through a series of different iterations. The current version is tokens 1.2, which was released just a day or two before with Corda 4.5. So this webinar will be focusing on Corda on tokens 1.2 basically, but from point to point where I see that there needs to be an explanation for people who have already gone through the actual token 1.0 or 1.1. I'll just let you guys know what changes in 1.2 because there has been a little bit of a few changes. But for people who are new to tokens, it's so there's nothing that you need to know from before, apart from knowing a little bit of from the Corda standpoint. But yeah, for people who are new to tokens, this is completely a beginner's tutorial or a beginner's webinar, I would say. Yeah. So let's move on. Well, just for the sake that you guys understand, you could ask all your questions on the on the chat, and I also have Sneha with me, who has joined us just to take care of you guys. He will be able to answer all your questions that you put on the chat. I'll try to take a look at those things from time to time and see if I could answer any of those questions if Sneha is falling behind because he needs to type it over there. And yeah, so let's just start. Well, so before we start, for the sake of people who have joined us for the very first time and are quite new to Corda, I won't probably take a lot of time, but maybe 5 minutes to give a brief on what is Corda, and so that you understand when I talk about certain different components of Corda with respect to the token SDK. So let's do a quick short recap, just like a 5 minutes one. Um, so from the point of view of writing a CorDapp, there are basically three essential components which you need to code. So the first one is the state. Now that's basically your representation of your asset. It contains all the properties of your asset. So if it's like a vehicle, it would have your vehicle identification number, your registration number. It would have things like who is the owner of the vehicle, who has manufactured the vehicle, and all this information that are that becomes part of the state. So this information is encapsulated in an object, and that object is called as a state. Now state as such is immutable. So this is the thing which gets so when you do a transaction, you basically create a copy of the state with all the updates, and then you consume the previous state, and the newer one which has been updated now becomes the most recent fact of the ledger, I would say. Yeah, that's how state evolve. This evolution is actually governed by something called as contract. We just don't put, let's say I have a vehicle, I just can't just change the ownership of the vehicle to someone else unless I just go through and verify certain validations, certain business validations. So these validations are taken care in the contracts so that transactions don't try to maybe do something which from a business point of view is incorrect, or they try to create transactions which to try to fraud people or something. So that's where all our business validations goes. So any state that you want to change, or any assets properties you want to change, you have to go through a certain set of rules which are written on the contracts. And finally, the flows. This is where you execute your business workflow. So when I say yeah, the values of or the properties of your state changes from changes according to the rules that are written in the contract, but that change has to happen according to a particular business workflow. So there has to be a workflow. Every business process has a particular workflow. So these workflows are modeled using flows. So that's a component of Corda through which you could basically write write different workflows to mimic your business workflows as well. So that's very much a pretty very high level overview. I just wanted to take a few minutes to explain these three components of a CorDapp, because we'll be using that going forward in our webinar today. Well, yes. So coming back to the topic of today's, so we'll be covering tokens for the next 1.5 hours or so. So what exactly is a token? Before we go deep dive into how tokens work in Corda and stuff, but let's first make sure and understand what is a token. We want to make sure that people understand token before they go into tokenization with Corda. So what exactly is a token? Well, when we talk about token, it's nothing but a digital representation of some other asset. Now, you could have different kind of token, like physical and digital tokens. So first of all, let's try and understand what a physical token is. Now, digital is something, just the digital representation of that. So if you're able to understand physical, we can very well easily understand digital as well. So what is a physical token? So if you see this picture over here, let's say you imagine you're going to a party and then you're wearing a coat or a jacket. So what happens at the entrance of that party is you're probably required to maybe because you don't want to wear that coat inside that party, and then you want to hand it over to someone who is standing at the entrance, and then they will give you sort of a token, a piece of paper which has written some number on that, and they'll keep a part of that they know that this particular number is related to this particular token, this particular code, right? So that's your token. That represents your jacket. It represents something like an ownership, right? It represents that you hold the ownership of that particular code, and then you could redeem that particular piece of paper or the token which you own when you come back after from the party, and then you take your code. So you redeem that token in exchange of your code, right? So in a way, that particular piece of paper is a representation of your code, right? And it also represents the ownership of that code, that you hold the ownership of that code. That's what a token is all about, right? So coming to the digital front, well, you might have heard of cryptocurrencies. There are a lot of tokens associated to cryptocurrencies, and then there is tokenized assets. Like, for example, you could have something like a real estate property which you tokenize to create so that multiple people can hold that token, and that would represent something like a fractional ownership of that token. There are a lot of other use cases which could come up, and that's how tokenization of assets works. So these tokens could be represented digitally, and you could hold them on a digital wallet. And at some point of time, you could do some transactions, like you could use it at a secondary market to trade those tokens as well. So that's what digital tokens are all about. Now, why should I care about tokenization? So before we try to understand or go deep into tokenization, we need to understand why we are doing tokenization, right? And why, in a business perspective, what is it that it benefits? What benefit does it give to business? Well, tokenization, first, there could be multiple use cases. I'll just cover a few of them. But there could be even more than this. I just put forward something which I think is most important from the point of view of tokenization in blockchain sense, or in general sense. 1.1 is security, right? For example, let's say you own a credit card, and then you want to do a transaction with your credit card. Now, if you pass on all the information of your credit card in a transaction, that might result in a security risk. Someone sitting in the middle a middleman might just read your transaction data, and he has access to all the sensitive data all the sensitive credit card data, right? So how could you the tokenization could help. So what we could do is basically you could tokenize your credit card information. So you could tell your credit card company that you want to send in you send in your credit card data, and then they'll return you a token. Now, that token wouldn't have any of your credit card information, but it would just represent your credit card. So when you do a purchase with that token, so basically you're just sending that token to the seller. You're not really sending any of the credit card information. So that particular token can be verified again from the credit card issuer, and then they could verify that the token is actually real, and then they could finally conclude that particular trade that you're doing. So in that way, what happens is, since you are not transacting that sensitive piece of information, uh, all your sensitive data is not going into in that particular transaction. So no one who reads that information in the middle will be able to access that data, that credit card information, because that's not there. So if something is not there, you can't really get access to that. Which also leads to reduced compliances, because we know that there are a lot of compliances rules which we need to follow when we develop a system of these sort which carry sensitive information. Now, if we have something like a token, then that compliance scope reduces, because if there are no sensitive data, then obviously less compliance to follow, right? So moving on, other piece of information is, or other sort of benefit that we could get out of tokenization is increased liquidity and market access. What that means is illiquid assets, like let's say a piece of real estate, or let's say a piece of art, right? A big mansion, let's say, which is like which is worth of millions of dollars, and someone wants to invest in that. You can't unless you have that much amount of money. You need to have that much amount of finance so that you can buy that and then hold it for some years and then sell it again to make any profit. But any property which is worth millions, you just, not everybody has that much of amount of money to be able to buy that and invest in that particular property. So what in fact can be done is, that particular piece of property could be tokenized, and then some X amount of tokens could be issued for that, and you could have partial ownership, that you could own maybe let's say 5% of those tokens, which you could really afford. Let's say if it's like 10 million, you might have something around 2.5 million, which is 25% of it, or maybe 500,000, which is like 5% of it. So this is something which would increase the liquidity of that particular assets, because now we have opened the door to fractional ownership, and more buyers could actually benefit from this, and they could even enter this particular domain where they would like to invest, which was earlier not possible because of the sheer price of that thing, which was only accessible to people who had that amount of finances with them. A similar case is for new financial products. Now, if you see something like, we could create new financial products with tokenization. Now, is that? That's because if you think of something like a loan, there could be others as well. I'm not much into finance, but loan is something which is very simple to understand, I think. So I'll take this example. If you think of something like a loan, which a bank gives, and they just rely on someone who is repaying that loan, right? So what can be done is, if that loan can itself be tokenized and traded in a secondary market, then basically you have actually created a secondary product out of that loan, and that is actually getting traded. People are buying it, and it also opens up a secondary market for the tokens to be traded. So that also in a way relates to the second one, which increases the market access as well. So yeah, that's a pretty high level overview of how tokenization could help. There are a lot of other things that it could do, but just to give you an idea. So moving on, how is tokenization working on Corda? What are we going to get? There's not much that I need to talk on this, but um, it's just that putting tokens on a blockchain provides you all those benefits which DLTs and blockchain in fact offers, right? So it gives high security, because tokens are issued on an asset which could basically, if that's on a central database and someone just gets access to that database, central database, it gets hacked, someone takes over the database, you might hold that token, but your underlying thing, which is which the token represents, or the underlying asset, that actually might get compromised, right? So which is not really a great thing. So having that in a decentralized way is really good. It increases security of the underlying asset. as well as as well as your token is really traceable, right? You could know that whether this token has been issued by a proper identity or not. You could see the entire history in an immutable ledger, which is stored on the Corda systems or on the Corda platform. And it also gives rise to decentralized governance. For example, you want to make sure how many tokens could be issued, and you want to check on that. But in a central database, you could just go ahead and update one of your databases, and that number just increases. But in a decentralized way, you have to go through these rules. Could be hard coded or could be coded, not actually hard coded, but coded in a contract, which means to do a transaction to increase the liquidity of that particular token, you have to go through a decentralized governance model, which would again require each and everyone to vote for that, to vote for getting the liquidity increased for this token. Which is again good to have a token, which is again one of the benefits of having token on a decentralized system. Right. Okay. So what exactly is a token in Corda? So when we hear the term token, the first thing that comes to us is like these kind of things, because we are so much used to hear token in these terms. We immediately think of it as some sort of cryptocurrency, right? But that's not really the case. When we talk of tokens in a Corda term, we are not talking about cryptocurrencies or for that anything that relates to that. We are not into cryptocurrency and we don't support that. So what is token exactly in Corda? Well, one is it's a digital representation of an asset, which I already said. But if you think of it from a more broader sense or a more deeper sense, then token in Corda is more of an agreement between two parties, which is an issuer and a holder. So the agreement says that from the issuer sense, it could be you could think of it as a liability, and then from the holder's end, you could think of it as an asset, right? So that's because the issuer who has issued that particular token is actually saying that whoever is holding this token could come back to me and he could redeem the sum or all the value of the underlying asset that that token represents, right? So if for the taking the same example of the quote thing which I just said while I introduced you to token, the issuer of the token, whoever is holding that quote for you, is issuing that token by saying that whoever is the holder of this particular token can come back to me and redeem this token in exchange of the quote. So that in terms become a liability, and for the holder, it becomes an asset. So that's how is the broader sense, or how we think of from a tokens perspective, right? Well, yeah. Moving on to our next slide, which is more about going into the technical details of token SDK. So what exactly is token SDK from an implementation point of view? So token SDK is something which allows you to create and manage tokens on Corda. So it allows you to do all this like different stuff like create, issue, move, and redeem. So when I say create, it's more like creating the underlying asset. When I say underlying asset, the underlying asset could be like on ledger asset or off ledger asset. You could have something like the asset itself could be on your Corda ledger, right? Like let's say a coin which you basically issue on the Corda ledger, and off ledger asset which is a house somewhere in Mumbai, and then you have digitized as you have issued tokens for this house. That house doesn't really exist on the ledger, but that's an off ledger house, but the tokens actually exist on the ledger. That's where we say on ledger and off ledger assets. So the point to understand here is create is actually creating the token type rather than the token. So the token type is actually in the example of the quote, the token type is the quote, and then the paper which you get, that piece of paper that you get in exchange of your quote is actually your token. So that's the token which is issued, while the token type is your actual quote, right? So the token type is your underlying asset, in this case the quote, and the token is the thing which is getting issued, which is the paper in this case, right? So when I say issue, you're actually issuing that paper, not the it has nothing, it's completely decoupled. So these are two different things. One is the token type and other is the actual token. And then move is when you move that token around, you want to trade with that token. So that's where you use the move function. And then redeem is where you basically come back and redeem your token. You destroy that token and take back whatever whatever you should get out of that, or the underlying some value of that underlying thing which that token represents, right? These are the functions which we can do with the token SDK. So it's more like a specification, I would say, groundwork done for you guys so that you could implement some of the interfaces and some of the components that are written already, and then it helps you to create and issue tokens on the create, issue, move, and redeem, all these things on the Corda platform. So what exactly is Token SDK? It's nothing but two CorDapps, which is the token contracts CorDapp and the token workflows CorDapp. Now, for people who had been working from tokens 1.0, you might have heard of two more CorDapps, which is the token money and token selection, which contained some of the money definitions and some of the coin selection algorithms. They have been merged into the token workflow with token 1.2 so that we have a less number of artifacts. So now it's just token contract and token workflow. So none of the functionalities are gone. They're all there. They're all merged into the token workflows. And we just have two artifacts now for the token SDK, which is token contract and token workflow. Yeah. So yeah, let's talk a bit about the token type now. So what are the types of token that we could have? When I say types of token, it's the type of the underlying thing. So what is it? It could be either fixed or evolvable, right? So when I say fixed, it's something like currency, right? Let's say something of sort $100 or 100 rupees. So basically, if it's 100 rupees, it will always be 100 rupees, no matter what. It will always be, none of the properties of that 100 rupees is going to change, right? It will always be issued by the RBI, and that value will always be 100, no matter what, right? So these things are fixed; they don't change over time. But evolvable tokens, these are the ones which change over time. So mind it that I'm just talking about the token type. We're not talking about issuing the tokens now. So token type means the underlying asset, right? So when I say evolvable token type, it's something like your car or a vehicle, right? If you want to issue something on, if you want to issue the tokens on a vehicle, you want to tokenize a vehicle. Consider this thing: the vehicle itself could change over time, right? So you might change the tires of the vehicle, you might change the seats of the vehicle, you might repaint the vehicle. So some of the properties of the vehicle are changing. So that's evolving over time. Your token or your underlying asset, which your issued token will represent, that's changing over time, right? So this is what we call as the evolvable token. So anything that changes over time is evolvable, and anything that remains fixed is fixed, right? So how do we now represent this from a Corda point of view? So this is how the hierarchy of the token SDK looks like. Well, we have the fixed token, which is our token type. So anything that is fixed needs to be a token type. If you want to create a fixed token type, you just create an instance of token type. And that token type is actually inheriting from something called as the tokenizable asset info. It's a simple interface. It has just one single field, which represents the denomination of that token. By denomination, I mean to say how many digits after the decimal point. So if it's something like you're issuing a rupee, it would be that the denomination will be 2, right? Because we could have 100 paisa is equal to 1 rupee. So, or in a similar sense, if you consider it from a dollar point of view, it is like 100 cents equal to $1, right? So that's where your the fractional digit comes into play. So just taking another example, you could have something like, if you want to represent a Bitcoin on the Corda ledger, then it would be 8, because there are because the number of decimal after number of digits after the decimal is actually 8. So that's what represents satoshis in Bitcoins, right? Yeah. So a little bit of something to understand here is the evolvable token type is not a direct subtype of the token type, and we'll try and understand why is that. That's because when you issue a token of a fixed token type, right? let's say you issue a token for a currency, right? Then you could directly say, if there is I'm issuing 100 amount for rupee, then I could say that this token is of type rupee, and I could directly embed that information onto the issued token. Because that thing is not going to change over time. That's always going to be the same, and it doesn't affect anyone. When whoever is holding that, it doesn't affect them, because the token type itself is fixed, and all that changes is the actual token that you're transferring. You might change the amount of that token that you hold, but your token type is always going to be the same. So we could directly embed that information onto the issued token. But think of it from a perspective of an evolvable token. An evolvable token will change, right? So if I hold some of the information, if I hold some of the tokens of a vehicle, and that vehicle has changed over time, then what that means is the token that I hold should also change, because I need to point to the most recent version of the vehicle, right? Which the token was issued. Now, if I hold a token, then basically whenever there is a change and in the vehicle, and that vehicle is directly embedded onto the evolvable token, that means that whenever there is a change, I have to update all these tokens, who are all these token owners, all these people who are owning those issued tokens. That also needs to change, which is really very tedious to basically, if I change something on the underlying type, I just go ahead and change everything, or for everyone who is holding that token, which is really a tedious task. So that's why evolvable token is basically that's why evolvable token is not directly embedded onto the issued token type, but it uses a pointer. So what we do is, whenever I'm holding a token of an evolvable type, then I use a pointer to point to the token type rather than directly embedding it. So that's why we use a token pointer rather than using the evolvable token type directly. Right. And that's again why the evolvable token type is a linear state and a contract, and which in turn is a contract state, which means it is a state in Corda because it evolves over time, right? So anything that evolves needs to be maintained on the ledger, and for that reason, it needs to be a state. All right. So again, the next thing to mention is token type, token pointer, and evolvable type. These are part of the token SDK, while the other things which I talked about, like the tokenizable asset info, the contract state, and the linear state, they are just part of the Corda core, which is the Corda platform. They're not part of the token SDK. All right. So yeah. So now let's move into issuing tokens, right? So this is where we talked about the token type. We talked about all the things about the underlying type on which token will be issued. So all this discussion was on the quote part of the thing, not on the paper thing which will be issued to you. So this is where we talk about the issue of the paper thing that we'll be issuing. So when we say issue some token, there are two things that would come into that two types of token that could be issued. One is a fungible token, and the other is a non-fungible token. So let's try to understand the fungible token. Just from first of all, let's try to understand the meaning of fungible and non-fungible. So fungible is something which can be broken and which can be like split and merged into at any point of time. Like for example, money or currency, right? 2000 rupees note is equivalent to 500 rupees note, right? So similarly, I could say that I have a 2000 rupees note, and if I have 500 rupees note, they are actually the same. But that can't be said so these things are fungible, right? So these could be one of them could be split into four, and then all four could be again merged into one. So that's where we say fungible. You could actually split and merge them anytime when you wish. But that's not the case for non-fungible stuff. You can't say that I have a house, and if I probably join two houses, I could get the same house. That's not the case. You can't say the same thing for these things which are non-fungible. So that's where non-fungible things, you can't break them. They are unique in their own terms. You cannot break them into two, right? So taking an example of the code thing again, which we talked in the beginning. So let's say if it's just you who is going to the party, and then you are issued that paper, you hold that paper. It's not fungible, right? It's non-fungible. It's unique for you. No one else can get that. No one else can actually claim that other than you, because that is unique. Now let's say, for example, you have a friend who is going with you, and then you don't know who is anyone. You want that anyone of both of you, probably one of you is planning to leave early or something, maybe for some reason. Maybe you want that both of you should have the right to collect that code back. So what the issuer of that paper thing will do is um, he'll basically issue a fungible token, right? He'll issue two papers to you guys, and he could say any one of you could take this, and then the other one will be marked as invalid. So something of this sort. So that's where we talk about fungible tokens, right? So there are two of them, which is there, and then that could be split and merged at time. Not really a great example, but I guess that would make some sense for from this point of time now. Yeah. So how do we represent fungible and non-fungible stuff on Corda? So that's pretty simple. You use the fungible token or non-fungible token classes. So if you want to issue a fungible token class, then you use a fungible token. If you want to issue a fungible token, you use the fungible token class. If you want to issue a non-fungible token, you use the non-fungible token class, and both of them would subclass from the abstract token, which in fact is a contract state. Right now the tokens will change hands, so the amounts and stuff will change, the ownership will change, so that's why it will change over time. So that's why it needs to be a state, and it's actually a contract state at the end of the day. All right. So that's overall uh, from the slide perspective. So let me just go ahead and open up a little bit of code and try to explain how these things look like in code. Right. Just a second. All right. So first thing we talked about is issuing or creating tokens, right? So whenever you want to issue token, you need to have a underlying asset that you want to issue the token on. So how do we create the underlying type? So to create the type, if it's a fixed one, you could use the token type directly. And we have something called as the money utilities, which gives you, which eases your pain of issuing something which is like a currency, a USD or a euro or a GBP for that matter. So you could use them directly, but if you want to issue something of something like, let's say, your own stuff, right? So for example, I want to issue a coin which is with my name. So I could say token type equals new token type. And if I want to issue a coin which is named after me, I could say this, and then denomination, how many fractional digits I will allow. So 2. That's how you create your own token types. If you want to, you could if you want more or more properties onto this. Currently, there are just an identifier and the fractional digit. You want more, you can always subtype that and create more. All right, so that's how you issue or you create a fixed token type, right? Now moving on to how to create a evolvable token type. This is how you create an evolvable token type. So yeah, one thing to mention is we have something called as when you want to create an evolvable token type, try and understand this will evolve over time. So this needs to be issued or this needs to be created in the ledger as a state, right? So we need to use some flows to do that. So for that, the token SDK provides you with something called as a create evolvable token flow, which is an inbuilt flow in the token SDK, and you could just use that directly. You don't have to just worry about how to select, how to basically create the transaction and then collect signatures and all this stuff. If you have the correct information on your token, the create evolvable token will do it all for you. All right. So coming back, like I said, the evolvable token is actually a state. Let's just look at this, how it looks like. So here you go. It uses the evolvable token type. I said it. I showed you the hierarchy earlier. It's a type of linear state, which is again a type for contract state. So it becomes a contract state, right? So your house state is a contract state. And one thing that differs here is instead of the parties, it has the maintainers. So we call this as maintainers, and it overrides the get maintainers. So these are the guys who should basically be informed when there is any change to the underlying type or this particular token type, which is evolvable. So that's how we, and apart from that, it's more or less all the values that you want to put in your token type. And so it's a house. So I would have, let's say, a valuation of the house, number of bedrooms, the construction area, any additional info, any address, and anything else that you want to put in this will come over here. So it's like a general state in Corda. All right. There's a fractional digit which we want to represent how many fractional digits that that whenever the token is issued would have. So basically, that's what your token type, your evolvable token type looks like. So coming back to creating this token type, it's nothing different from creating a normal token type, a normal state. So basically, you just create the instance of the token type, which is house state in this particular case. And then whenever you want to, there is this contract, the transaction state, which is basically a wrapper of the contract state, right? For any transaction that we want to create, we actually don't. So the transaction builder itself has a method to take in the contract state itself, but internally it converts it into a transaction state. So we need to pass in the transaction state to the create evolvable token. So the transaction state is nothing but a wrapper around the contract state, and it has certain more metadata like the notary and the constraint that this particular state uses. So that's not much that you have to do. All other thing to create a transaction, all that you have to do is create a transaction state is just pass in the contract state and name the notary. That's it, and that will give you a transaction state, and then just pass it to the create evolvable token workflow, which is provided as part of the token SDK, and that will create the token type for you. You don't have to worry about anything about signing and then calling all those other things like verifying the contract, or even like collecting your signatures from others. So that all things are taken care inside this particular flow. All right. So that's where we'll talk about these part later on. This is where we issue it. So for now, we're just creating it. So once we have created it, now the next thing that we want to do is basically issue your token, right? So we created the underlying token type here, which is the underlying thing, and then we want to issue tokens on that thing. So how do we issue tokens? With Corda, with token 1.0 or 1.1, there was a long process of creating it. You had to create a lot of different things like you had to create an issued token type, and then you had to create you had to pass into to a non-fungible or fungible token which you want to issue. But things have been made a lot easier now with token 1.2, and we now have builders. Just like the transaction builder, we have builders for fungible and non-fungible token. So if you want to issue, so let's first look at a fungible token builder. So if you want to create or issue create a instance of token fungible token, all you have to do is use this builder, and it becomes so easy. Just check it, this code. All you have to do is create the builder and pass in all the information. So it needs a token type. So the token type is the one which we just created, and then it needs an amount. It's a fungible token. You need to specify the amount of that fungible token. So just pass in a value, a long value, that this is the amount of token that I want to be that I want in this fungible token to have. And then you just say who the issuer is. So obviously whoever is calling this particular flow is the issuer. So we are using the get our identity. And then you just say who is holding, who should be the holder of this particular token, and that's the recipient, which will be passed on our from our flows, or whoever is triggering this flow will pass in the recipient as a party. And then we call the build transaction, build fungible token method, which will create the fungible token instance for you. So all those things earlier which we used to do are just taken care within this builder, and you don't have to worry about that, how that works internally, right? All you have to do is call this and pass in all the required information, and that will create a fungible token for you. Now, one thing that is left is I have an instance of fungible token. All I need to do is issue this token to the party, or pass it along to everyone who should know about this. So for this case, the recipient, right? So you don't have to do much. You don't have to worry about verifying it, signing it, and collecting signatures, calling the finality flow. None of them has to be done. Just call the issue tokens and issue tokens flow, and which is again a part of the token SDK, and then pass in your token and the recipient, and that will take care of all the underlying steps that should be taken care of. And that's it. Your token will be issued, and you can see it in the ledgers of all the participants. It's pretty much similar for a non-fungible token as well. We have a non-fungible token builder, and it again takes a token type and your issuer, your holder, and you finally call the build non-fungible token method. One thing to note is, like we talked about the pointer. So your house state is an evolvable token. So we are not using it directly, but you need a token type here. So we will use the pointer. So we convert this house state to a pointer using the toPointer method. So there is this method which you could conveniently use to create a pointer out of evolvable state, right? Evolvable token type. So that's pretty simple as well. Just call the toPointer method and pass in the type of your evolvable token and evolvable token type, and basically that will give you a token pointer, right? The only thing that doesn't, only difference between the non-fungible builder and the fungible builder is that it doesn't have a amount, which is quite understandable because non-fungible tokens are unique and you don't really need an amount in there. Right. And then again, the issue tokens, which is again very simple. Just call the issue tokens with by passing your token to it, and it will take care of all the other things, all the underlying things that needs to be done. All right. So that's pretty much on how you create an issue. Let's move on to something like uh, move, or redeem. Right. I'll show a different example for this one. This doesn't have. This is more of a simple one. We just talked about the create one and the issue one. So this is again the similar thing that has been done there. If you could see, create is just, this is again a fungible token, and so we create a type of a fungible, we just create an instance of the token, and then we create a transaction state, and the create evolvable token function is called, or the workflow is called, flow is called, and then this will create the token, and we have issued it to someone here who is the holder here. And the issuance is again pretty simple. We just create, we just get it from the vault, the token. We get the token type from the vault, and then we convert it into a pointer. We get our issuer, we get a holder, the amount, and just call the build fungible function, which is again issuing. We talked about this earlier. Last thing we want to talk about is move and redeem. The move and redeem are very, very simple. All you have to do is call the move fungible token method and pass in the amount that you want to move and the holder who should be holding that moved token, right? You create your, you get your type, and then you create an instance of amount, and the amount needs a quantity and the type, token type, right? So the token type can again be fetched from the vault, which is why we use the vault service to fetch the token type. We query the fungible token house, and then we fetch the state and ref from there. From there, we get the actual contract state, and from the contract state, we use the toPointer method to get the token type for this, to create the amount instance, right? Again, the token state or the fungible house token state is a evolvable token. So we need a pointer. So toPointer method. And then finally, just call the move fungible token method, and that will do the rest for you. Here is just your the other end or the responder end of that thing. You just need to write it and call the handler, which is your responder function for the move fungible token. Just like you have responders for every other flows there in Corda, there is also a responder for move fungible token, and you call the and you just need to call the move fungible token handler so that everything in the background happens correctly. Right. Last thing is to do the redemption, which is to burn the token. So generally, the use case would define how you do redemptions. Probably you would want to get back the some value of the underlying token, but here we're just trying to burn it and see how we're just trying to burn the token. So we just pass in an amount in the redeem token function, and who has issued that particular token, and that amount of tokens would be redeemed, or in this case just burnt, so that will go out of existence. That's it. That's what your redeem is doing here. So these are the major four things that we do. We do create, we do issue, we do move, and we do redeem. So all grounds covered, I guess. You create the underlying token type, you issue tokens, you move tokens, and finally you redeem tokens. This is how the entire life cycle of tokens work, right? So just to show this in practice, I'll just go through, I'll just try to run this particular sample in front of you guys and see, so that you get more clarity. So let me just build this. To do that, all I have to do is gradle w deploy nodes. Oh, missed a w there. And it just takes a few seconds to deploy, or oh, there's been a problem. All right, I'm probably not on the right path. Okay. Oh, I missed a P. All right. So just a little bit of a typo there. So we'll just wait for a few seconds while this complete. It doesn't take a lot of time anyways. And once this is done, we should be ready to run our nodes. All right. So the deployment is done. So we have all our network artifacts available in the build nodes directory. Now we're ready to run our nodes. So what we can do is just say build nodes and run nodes. So that should bring up all my nodes, and I can see them right here. Right, I have the seller, I have the notary, and I have the buyer. Okay. Just give it a minute to for the nodes to start up. I guess I'm missing one node. Right, this is the seller. That's the notary, which I'll not mute. Okay, all right. This particular command wasn't executed. This is the friend node. Yeah, I'll explain what these nodes are. Just give me a second while they come up. Right. Just one node remaining. While it comes up, I think we can still start. All right. So let me open up the Node Explorer so that we can have a visual view of what's happening in the nodes. All right. So the Node Explorer is up. So don't worry about the fonts on here because I'm not going to show much here. I'll use the Node Explorer. So just in case you are worried that you're not able to see the fonts, just have to remember what are the nodes. We have the buyer, seller, and a friend, and obviously a notary, which will not be talking about much in this one. So we'll start with the seller. Let's go to the seller node. I'll just log in to the seller. Let me check once what is the port for the seller. It's 10,006. Yeah, that's right. User 1 and test. Okay, we are logged in. Let me just see if I have the correct setup. Yeah, perfect. So there are different flows which we talked about. We talked about the create, issue, move, and redeem, right? So let's move and try to create our underlying token type or the asset that we want to tokenize, right? So we want to tokenize a house. So that's why we will create. Let's just give it a symbol so that we can identify the house, right? I say it the HSE, and just a valuation just for the matter of making it evolvable, but you might have different things as well, so let's not worry about that. Just pass in a valuation, right? When I say execute, the transaction is successful, and you could see that this particular fungible house token was issued onto the ledger, which could also be verified over here in the vault, right? So that's unconsumed, and I have it in my vault available. Now, what I could do now, since I have this house, I could tokenize this house, right? I could issue tokens on this house. So I'll say that let me issue a token on this house for the buyer, and someone is buying this token, let's say. And so I've issued some tokens. What I'll do is I'll go into issue house token, and the symbol for the house was HSE. The quantity is the amount of token that I would really want to issue for the buyer. Let's say I'm issuing 1,000 tokens, right? Who the holder is, it's the buyer, right? And then let's execute. Okay, so when this is done, you could see one more transaction. This is the issue token transaction, and 1,000 tokens have been issued to the buyer, which you can't really see here because the token is not being held by the seller, but it's with the buyer. So I'll have to log into the buyers to check his vault and see if he has the tokens. Just let me verify what's the yeah, it's 10,009. The port is 10,009, right? User 1, and again this test. Yep. So now I'm logged in as buyer. You could see the same transactions, and if I go to the vault, I have one more state, which is our fungible token, and the amount is 1,000. But for if you're using it from a front end or something, then I have this convenient method or a flow which is written called the query token balance. And I could say I want to see how much token do I hold of a token of the HSE token of the HSE token, which I have provided as an identifier. So you could see that you currently have 1000 HSE tokens, which is a message that I get from the flow. Right. All right. So we have done an issuance of the token. We created the underlying token type, which was the house, and then we tokenized the house, and we created and we issued tokens to the buyer. So the seller is holding the house, and then he has tokenized the house. He has issued 1000 tokens to the buyer. In turn, in real practice, there would have been some other transfer of value or something, but yeah, just for the purpose of understanding tokens, let's not go into use case that you could basically identify how the use cases and then probably just change this according to that. But just considering on the implementation of tokenization of the or the technical aspect of the token SDK, that's what I'm trying to demonstrate here. So we have done the issuance. It's time to try and the move function, right? So I'm the buyer and I want to probably uh, give some of the tokens that I hold to one of my friends. So that's where I have a friend node, right? Say for that I'll use the move fungible token flow. And then the symbol of the token or the identifier, which I used is HSE. With the holder will be friend, and I have 1000. Let me pass on 600. So I'll pass on 600 to him. So which means I should hold 400 and he should be holding 600 after this transaction is done. So hitting execute and the transaction is completed. There you go. So you get a good UTXO kind of thing here. So you had 1000 as an input to the transaction, 600 was moved to friend, 400 is retained by the buyer. I can validate that with my query. Just say HSE, execute, and there you go. You currently have 400 tokens with you. And obviously the 600 would be with the friend, right? Let me log out, go to the friend node. Again, let me check what's the port, and it is 10,013. All right, 10,013. User one, test the normal username and password we use for all our samples. Okay, this is the friend node. He should have 400 or 600, I guess. What is the one which we passed? Let's just check. Yeah, 600 is the thing which we passed. So this guy has 600 tokens. All right. So the last thing that we could do is redeem these tokens. So I have 600 with me. So let me try and allow maybe redeem around 200 HSE. And who issued this token? Seller issued the token. Remember, the buyer, who was friend's friend, had just passed the token to him, or given it as a let's say a gift. But the actual issuer was the seller, right? So I have 600. Let me just burn 200. So if I go into a real use case, I might get something. So it would be more of a DBP transaction where I do a redemption of 200 and then get some value of the underlying asset. But that's not the case here. It's not a DBP. We're just using a simple redemption just to not make it very complicated for you guys. And there you go. We have redeemed 200. So what happens is out of 600, 200 was reduced. So basically 200 of it was burnt, and what is left is 400, right? Which you can again verify from your query, HSE, and execute. So 400 left with me, 200 is burnt. All right, that's pretty much of it. And let's move back to the slides. So yeah, here we go. We explained about this thing, and here are all the inbuilt flows that we have in the token SDK. We talked about create and issue. Create evolvable token, create evolvable token handler if you want to just go ahead and check what is happening in the responder part of the things. Then you could just check those out. Issue also has a responder. So all of them has a responder basically. Issue for issue, it's issue tokens handler. Similarly, we talked about move. So you have two different inbuilt flows. If you want to move fungible tokens, you use the move fungible tokens and the handler for it, or the responder part of it is written in move fungible token handler. Similarly, we have non-fungible move, and similar is the case for redemption as well, right? So a pair for fungible and a pair for non-fungible redemption. And finally, we have something called as the update evolvable token. Now, we have been talking about this, that evolvable token is at the end of the day, it will evolve over time. So we need to have an easy way to do that. We need to have an easy way to update an evolvable token, right? So for that reason, we have the update evolvable token and update evolvable token handler. So anytime you want to update your token, so you just say that you just call the update evolvable token handler, and it takes care of distributing, or one, updating it, and then the other thing is distributing all those update to every maintainers who are there in the token, or the token type basically. Yep. So that's pretty much from the token SDK today. So if you want to try it yourself, the two samples that I showed are available in the token, or in the samples Java and samples Kotlin repositories. You just go into the tokens folder, and there are different applications also, including, or there are different sample token apps, including the two which I just showed you today in this webinar. So feel free to just go ahead and download those right out. Let me just share that a little bit and show you something interesting. All right. Okay, here I go. Okay, here you go. This is where you find all your, this for the Java one, you will find them for your for the Kotlin one as well, if you're interested in Kotlin code. So we have just recently added this try with Web IDE as well. So if you want to try out a particular sample, you want to download it onto your system because probably you haven't set it up, then what you could do is just click on this thing, and it will take you to the Web IDE where you could just play around with it, right? So it's just opening up. So it takes a bit of a time because for the very first time, it's been up all those resources for you in the backend. But you see that we have all your workflows and the contracts all available, and it has downloaded all those things, and the setup is all done. And so you could just try it out over here directly on the Web IDE, just in case you're not able to get the setup right. So just you want to do a quick experiment, so try this out. Yep. So coming back to the slides, yeah, that's where. And if you want, if you're really interested in the source code of the token SDK, the place you go is GitHub/Corda/token SDK. That's where all the source code for the token SDK resides. I already showed you the fungible token, fungible house token. And there are a few other samples as well, like the stock pay dividend mic market, and these are a bit of an advanced thing. So if you, once you're comfortable with what I have shown today, with the basics of these things, then just go ahead, try to see what's going on in there and how these kind of real world examples would really look like. Right. Well, that's it from the webinar today. I think we have covered most of the token SDK part. I did show you a small demo as well. So if you want to continue, I like to stress to go to the training, the free training, which we have, a free training site, which we have just launched last month or so. So just a big shout out to everyone who wants to learn Corda on Corda more properly. Then we have or the tokens more properly, we have a section dedicated to tokens in the training as well. So feel free to check that out. You want to communicate or you want to talk to other CorDapp developers in the community, check out our Slack ledger, Slack Corda ledger. That's a public Slack of more than 8,500 Corda developers over there, including people from R3. So you could reach out to us there. Go to docs for anything that you want to know about Corda. GitHub repositories out there. You want to contact Devrel, we are there on Slack as well. But if you want to email us, it's devrel@r3.com. Tweet us, Corda @Corda blockchain or @inside R3 for R3. Use the hashtags #Corda and #R3. Our YouTube channel, I guess you already know this. It's YouTube/Corda blockchain. Well, that's it from my side today. Thank you everyone for joining, and I hope it was a very constructive session for you guys today. Thank you so much, and we'll see you in the next live stream.